Alright, thanks for watching, and today I will do two things at the same time. I will first introduce you to cylindrical coordinates, and also I will show you how to do integrals in different directions. So let's try to figure out the triple integral of the function square root of x squared plus z squared, where E is the region bounded by this weird figure and the xz plane. So as usual, we draw a picture of this weird solid xyz. And well, let's figure out what this weird surface is. Well, if you had something like z equals 4 minus x squared plus y squared, well, that would be a paraboloid, but that's upside down. So z equals that would look almost like this Pac-Man evil thing, like this, in blue and stuff. But this time, what's interesting, it's a paraboloid, but in a different direction, namely the y direction. So what you would do, you would draw this in the z direction, but this time facing the y direction. In other words, you tilt your head and you draw the same thing here. So this indeed becomes zy equals 4 minus x squared minus z squared, which again faces the y direction. And the fact that it's the xz plane just tells you you're just cutting it off at this plane here. So let me draw this a little bit better. Kind of like that. Okay. So it's kind of reverse, like a kamehameha, but in this direction here. So, and what's interesting is it already tells you sort of which direction we have to do the integral with. Well, of course, here you have to do an integral in the y direction. And again, that is, our solid E. And what this integral calculates, if you want, it's the mass of E, where the density is square root of x squared plus y squared. Okay, so that's one thing. And then, next thing is we have to find inequalities. Well, usually you start with z first, but because it's facing the y direction, you have to do y first. And so, it is still y is between bigger and smaller, but now you have to tilt your head. So, if you're tilting your head, the bigger function here becomes this paraboloid. So, y is between big and small. And so here y is between 4 minus x squared minus z squared. And the question is, what is the smaller function? Well, it's precisely the xz plane, which has the property that y equals 0. So indeed, y is between 0 and x squared plus 4 minus x squared minus z squared. So that's the first thing. If you do an integral in a different direction, you have to figure out which direction your figure is facing in, which usually it's not that bad, sometimes a little bit trickier. And then in this case, you have to rewrite your new inequality, here y, still in terms of bigger and smaller, but depending on where your head is facing. That's the first thing I wanted to teach you. The second thing is, well, notice, we have minus x squared minus z squared. we have square root of x squared plus z squared in our function, and we have this circular thing going on. So that's a good motivation to use polar coordinates. Except it's just a terminology. Because we're in 3 dimensions, it's not quite polar coordinates. It's called cylindrical coordinates, which again is just the same thing you've been usually doing. So in the xz plane, using polar coordinates in x and z, what this becomes is just 4 minus r squared. Where r, if you want, is the radius in the xz plane. So this is x and z, and then we still have r and theta. So r is the radius, which becomes square root of x squared plus z squared, so the square of that is r squared. Alright, that's one thing. Now, the second question is, what about the region D? So D, if you want, is just the base of your solid here. And to figure it out, you just need to set y equals 0 in this equation. Because in this case, it's just given by the intersection of the two. So I will draw that again, don't worry. So if you set y equals 0 in that, you get 0 equals 4 minus x squared minus z squared. And therefore, x squared plus z squared equals 4. So what D becomes is just a circle or a disk of radius 2. So if you just want to draw it this way, this is x and z. D is literally a circle of radius 2. Which, again, you can just write conveniently in terms of polar coordinates or cylindrical coordinates. In other words, the radius here, it's between 0 and 2. And the angle is between 0 and 2 pi. Alright, and now with the inequalities, we're ready to tackle the problem. Again, just to emphasize, cylindrical coordinates, still the radius and the angle, but then the other variable, in this case y, it's still the same thing. So usually it's z, but in this case it's y, because you're facing the other direction. And then you just do the math, so pi m method. Because picture pi m, inequalities pi m, and math pi m, okay? Then, what do we have? The triple integral over e of the function square root of x squared plus z squared dx, dy, dz. What this becomes, it's the triple integral. We had y is between 0 and 4 minus r squared. So, dy. Then we saw r is between 0 and 2, and then theta between 0 and 2 pi. So dr d theta. But then what we get, so y is between 0 and 4 minus r squared, r is between 0 and 2, theta is between 0 and 2 pi. Now, square root of x squared plus z squared, what it is just the radius. So we have x and z. And then if you have a generic point x comma z, the radius r is just the distance between x, z, and the origin, which is this. So what happens, this just simplifies to r. And last but not least, you just have the Jacobian as usual, which is r dr d theta. But in this case, r dy dr d theta. And then you calculate this, which you'll see becomes much simpler. So first of all, there is no theta, so it's just 2 pi times whatever. and then integral from 0 to 2. And then this is just constant with respect to y. So what this becomes, it's r squared times b minus a. So 4 minus r squared dr. And then you just have to calculate this. So 2 pi times the integral from 0 to 2 of 4r squared minus r to the 4th dr. And then you do this, so it's 2 pi times 4r cubed over 3 minus r to the 5th over 5 from 0 to 2. Now, this looks very hard to calculate. It turns out it's much easier than you think. So it's 2 pi times 4 times 8, which is 32 over 3, minus 2 to the 5th, which is still 32 over 5. And so if you multiply this by 2, you get 64 pi times 1/3 minus 1/5, which becomes 64 pi times 5 minus 3 over 15. 5 minus 3, that's 2, times 64, that's 128 pi over 15. So lots of pi, but also lots of people. So not sure how much fair share you get. That is the answer, and I just want to say, in general, here we were lucky because stuff simplified to r, but the question is, how do you do it in general? Well, again, it's just polar coordinates. So in general here, the equation for x and z, it's simply r cosine of theta and r sine of theta. And then y equals y. So that's the equation for cylindrical coordinates, but in the y direction. And I really want to emphasize, don't just blindly memorize that y equals r sine of theta, because here we are facing a different direction. Alright, I hope you like the cylindrical extravaganza. If you want to see more math, please make sure to subscribe to my channel. Thank you very much.